really excited to be here today. This is our second event called a MedTech Talk in partnership with the Venture Cafe Providence. And each month at 10:30 a.m. On the second Tuesday, which is today, we'll be hosting a small 45-minute workshop talk, kind of educational session that showcases leaders in the MedTech space and any kind of space related to that space from around New England and working in New England. So just to give you guys all a little sneak peek too, before we kick off today's next month, we have lined up the lead designer of digital therapeutics at Teva Pharmaceuticals, which we're really excited to have. So there'll be more information coming on that if you guys tune into the Venture Cafe, newsletters and marketing. So let's kick off today. So today's talk will be hosted by Peter Haas around Humanity Centered Robotics and Augmented Reality. Peter is the Associate Director of Humanity Centered Robotics Initiative at Brown University. He was the co-founder and COO of XactSense, a UAV manufacturer working on LIDAR mapping, which I don't know what this means, Peter, so I'm excited to hear, and autonomous navigation. Prior to XactSense, Peter founded AIDG, a small hardware enterprise accelerator in emerging markets. He has received both TED and Echoing Green fellowships, and has been a speaker at TED Global, the World Bank, Harvard University, and many other venues. He also holds a philosophy business degree from Yale, and I will turn it over to him. Thanks, Peter.
Thank you so much. Yeah, so I know this was billed as a MedTech talk, but this is one of those talks that's in an associated area. It's National Robotics Week this week, which is very exciting for me working in robotics. And I thought I would share this week a little bit about what is going on in the world of robotic avatars. Which sounds like a crazy futuristic thing, like that movie, but it's coming. So I'm gonna just share my screen. What I want to talk today about is really the concept of digital twins. And I want to talk about digital twins and robotic avatars because this is what is going to bring robots to the forefront. And I know people have been promising you this for decades. People have been saying since the Jetsons that the robots are coming. And you saw in 2001, The Space Odyssey, HAL 9000, you saw The Terminator, you saw all these movies, Blade Runner, that were supposed to have happened by now. We're supposed to have the robots. Where are the robots? Well, the robots are coming. And my job over the next little bit before we get into discussion is to convince you that indeed the robots are coming. They're on their way. They're going to be here shortly. And so to do that, I want to just preface that we are in the beginning of a new industrial revolution around robotics. So just to give historical context, our first industrial revolution started here in Rhode Island at Slater Mill. And it was all about mechanization, water power, steam power. The second industrial revolution, you had the automobile, mass production, the assembly line, electricity. The third industrial revolution was our computer revolution and the early stages of automation in structured environments. And the fourth industrial revolution is what we are entering now. And it is about cyber physical systems that make decisions and can actually perceive the world around them. And this is going to have a big impact on us actually seeing robots. And to give you a sense of how big this impact is, I'm going to go back to the second industrial revolution and the start of that industrial revolution. And the task in this this slide here is to spot a car in New York City in 1900. and I made it kind of easy. I circled the car. um, but basically, there was one car in 1900 in New York City in a parade of horse-drawn carriages. Now, you fast forward 13 years, and the task flips itself. The task becomes spot a horse-drawn carriage, which again I circled to make it easier, in a parade of cars. Okay, so about a decade, total sea change, like completely different environment. And that's what I'm try and convince you that we're entering with robotics. We're about to enter a totally different world here. And it's a really exciting world. And it's a world that's going to become familiar to us, and the standards that we set now are going to be the standards for years to come. So just to give an example from the third industrial revolution, computers, um, in 1975 you had the Altair, and the Altair was programmed with punch tape. Okay, by 1984 and 1985, for the sake of going a decade, you get the Macintosh. So you get the GUI, which becomes the basis for all of our computing until today. Okay, the interfaces that we developed around the GUI in 1984 really, and I mean, it was pioneered a little bit before that in Xerox PARC and research, but became commercial in 1984. Um, they became the standard by which we interacted with the computer. Okay, and that's what we're entering into with robots, is we are setting the standards now by which we are going to interact with robots. And the reason why now is a really special time in robotics is we've made huge advances in two areas. We've made advances in perception. So robots are now able to perceive the world around them. Okay. And we've made some advances in decision making. Okay, robots make better decisions on simple scales. Okay, so it means that things like self-driving cars, and this is the Stanford Stanley, which won the first DARPA Grand Challenge in 2005. The DARPA Grand Challenge was a challenge to have a self-driving car drive itself across the desert. And it was a course that it was about 100-mile course across the desert. And the Stanford Stanley was the first car to complete it. The year prior, no car got more than half a mile. Okay. So massive change in just a year. And by 2012, you had the Google autonomous vehicle in research. And that was able, like, I drove in the Google autonomous vehicle, and that thing laid the rubber on the road in 2012. It was an incredible ride. Um, and I was convinced in 2012 that self-driving cars were going to be everywhere in a couple of years. And when I rode in that car, I was talking to the engineer about it, and he just laughed. And he laughed because the LIDAR on the roof of that car cost $75,000. Now, what's happened in the past decade is all of these components have gotten cheaper. So the LiDAR that was $75,000 went to $30,000, then $8,000, and $500, and now you're talking about sub $100 LiDARs that can do pretty much what that $75,000 LiDAR could do. Okay, so all these components for sensing and perceiving are becoming cheaper and cheaper and cheaper. And it's meaning that they're commodities that can be integrated into every robot. Um, Now, the question is this progress in perceiving going to be enough to be able to solve our problems of autonomy, of getting robots to be able to work autonomously out in the world? And Rodney Brooks, who's a famed roboticist, who's co-founder of iRobot and Rethink Robotics, uh, famously said, quote, that Moore's law and exponential laws like Moore's law can fail. That instead of being on an exponential curve in computing power, which is permitting this decision making, we're on an S curve and it's going to level off. Um, and I think that that is something very important for considering the state of the art of robotics. Because if you look at the state of the art right now, um, robots really get stuck on that complex decision making, on that complex planning. Okay, so let's look at this video here of a robot trying to stack a box. This is an Atlas robot that's famous for doing backflips from Boston Dynamics. And as you can see, it is having a really hard time stacking that box. And the reason is it lacks all of the basic understanding of everything around it. Okay. All that kinesthetic awareness that we get as kids, knocking things over and falling down, this robot does not have. It just has a point cloud. And outside the fiducial markers on that box, marking the box as something special, it doesn't know what anything is. So let's look at another robot. And this is a robot video that was taken over 12 years ago at this point, much older than this robot. And this is a robot doing a cleanup task. It's a PR1, it's sped up, but it's a PR1 research robot doing a cleanup task. And it is doing this task very well. It's cleaning up that room. It knows where everything needs to go. It's putting it away. It's making it nice and straight and looking good. And the question is, how is it doing this? It's doing this because it's doing it in it's able to do this because it's doing it in partnership with a human. There's a human teleoperating that robot. Now, if you've ever tried to teleoperate a human robot with existing interfaces like keyboard or joystick, you know it's really hard to do. So how did they do this? They did this using a VR, or sorry, using a mechanical gantry system, okay, like the Da Vinci surgical robot. So they actually had a mechanical system that recorded where people moved and turn that into motion for the robot. Now that's pretty expensive. But what we found at Brown is that you can replicate that kind of system in VR. And a couple of years ago, a couple students and graduate students got together and they started exploring virtual reality control of robots. And they wrote the first open source bridge between robots and Unity, the game engine. So just to give you a sense, the current approaches to moving a robot, you can physically move the robot and train the robot where to go for repetitive motion. This is called kinesthesis. You can use a computer monitor and set up a motion plan for the robot and have the robot execute that motion plan. There's like a homunculus control where you kind of move things around on a screen and you see different views from the robot. It's like that movie. Oh man, I'm trying to remember the name of that movie. I can't remember it. But with the little cartoon characters in the brain controlling the person. Um, this is like that. That's the homunculus control. But the approach that we took at Brown was this virtual gantry approach, where you use virtual reality to move the robot's arms around. And it's a very intuitive approach for controlling the robot. Um, and this solves all those problems of the robot knowing where things go and knowing what to do with things and how things will react in the physical world. It leverages that basic human kinesthetic understanding. So it's a very powerful tool, and it's totally open source. You can go and download Ross Reality right now, and you can set it up on your Steam VR setup, your gaming virtual reality rig, and you can connect it to your robot if you happen to have a robot. If you don't have a robot, we're working on solutions for that. So stay tuned. But we found that this was a very effective way for novices to control robots. And the students who were running this did a study comparing kinesthesis like this in executing a task to trying to do it with a keyboard and monitor to doing it with the virtual reality controls and a screen to doing it entirely in virtual reality and using the Ross reality system to control the robot to accomplish the same task. And what they found is that in doing these tasks, the same task of stacking, using the NASA TLX and the SUS frameworks for measuring the feasibility of the task and the ease of the task. They found that the Ross reality control, kinesthetic control was much faster. Kinesthetic control, obviously being proximate to the robot, moving the robot yourself, easiest way to do something. But the Ross reality approach, the virtual gantry approach, was the second fastest. It was almost the least workload. It was just as usable as being next to the robot. And it was just as appealing as being next to the robot. Okay, so it was just as good as being there to be controlling the robot in virtual reality. And then they expanded this and they tried a whole number of different tasks. And what they found is this robot in virtual reality could do a whole bunch of things. It failed at stacking blocks. It wasn't able to peel a potato. Okay. But it was able to do a bunch of things like uncap a marker, dispense sanitizer, use a dustpan. So like pretty complex tasks for robots to do, it was able to accomplish in this interface. And what they found is it was also something that was low enough latency that they could accomplish it over great distances. So this is an example of them trying it between MIT and Brown, controlling a robot at MIT from Brown, and they were able to control the robot just fine, as if they were there. Um, and the other great thing about this is they found they extended into mixed reality. Okay, so the same system that was used for virtual reality could be used for mixed reality to project what the robot is about to do. Okay, so it's roughly the same software. Um, and what it ultimately did was it allowed for the projection of motion plans by the robots. So it allows the robot to communicate its intention to you. Now, this might not seem like a very big deal because like we're used to dealing with humans who communicate intentions all the time using gestures, facial expressions, little subtle clues that we pick up on. But if you're in an industrial setting and you're faced with some robots like this, you really have no idea where they're going to go or what they're going to do. And that can be really dangerous. But imagine if you were able to see in augmented reality that the robot was turned off or that the robot was moving in a certain direction. That would be very, very powerful. Um, Now, this is still research technology, but it is about to become big business. There's a $10 million X Prize going on that is in the semifinal stages. I'm a semifinalist in this, so I'm putting my little plug out there for my little avatar robot that could. But yeah, so if you're interested in getting involved, let me know. But basically, these robots are being done at a commercial level. Like that was an open source robot that we're developing. But I mean, people are developing very serious commercial robots for this teleoperation. And as you can see from Jeff Bezos here, having fun controlling the robot, uh, this is becoming very advanced technology. And it is really at the stages where it's about to hit the marketplace. So what does the future hold? The future holds a future where perhaps lots of robots are going to be controlled by one human. And perhaps there's going to be a partnership between the humans and the robots. Now, what are the wider implications of this? Well, the labor implications are pretty intense. About 3.4 billion people live on less than $5.50 a day in the US. Many of them work as physical laborers. Okay. So that concept that's gotten into the public zeitgeist that robots are going to take your job, well, with the help of people in other markets controlling the robots, that may be true. And it is concerning for developed economies like the US because automation alone is having a big impact. So automation already with robots in manufacturing in the US ended up reducing the labor pool in manufacturing from the US between 2000 and 2010 by 5.8 million jobs. So between 2000 and 2010, we produced just about the same amount of stuff, but we did it with 5.8 million fewer people. And according to a study by Ball State University, this was 80% attributable to automation and robotics. So our future is going to be very different. But I personally, despite these concerns about the job loss and the job transitions, believe it's going to be a bright future. I believe that this technology is going to enable us to do things that we have never dreamed of before. Things like create colonies on the moon, or mine asteroids. Like there's going to be a lot of interesting things that this technology enables. So with that, I'm going to stop my screen share and we're going to go into a quick little discussion. And I want to be cognizant of time. Amy, could you give me a sense of how much time we have for the discussion?
20 minutes.
20 minutes, great. Um, so yeah, opening up to questions here. If anybody has a question, I think we're a small enough group that we can just go off mic, go off mute and just ask the question. So anybody have any questions?
I am now facing a difficult time because family is getting COVID-19 and they are at the hospital. How do you see that these products, especially for teleoperation, will help to work in pandemics like right now?
Yeah, so there are actually some hospitals that have been deploying robots into COVID wards for telepresence. We looked into doing this with Rhode Island Hospital, and unfortunately, the project did not go forward. But there there are a lot of reasons that people could want to be close to somebody and not be able to be close to somebody. And the avatar technology, I mean, their goals are very lofty with that X Prize. Their goals are for you to be able to actually have the sensation of touch when you're wearing the VR equipment. Be able to actually like have the motion capabilities so refined that you could pick up an egg or like gently stroke an arm or something and have that actually be conveyed as a response and emotion. So I think that this technology is really going to help in situations like COVID ward treatments, be able to give human care through robots. And unfortunately, we're still a few years away from the technology really being mainstream. So, yeah.
Or I think, or at least some kind of hologram to project people. Not you cannot work with you cannot have a robot, but you can project your personality on a screen.
Yeah. And again, there are a lot of hospitals that are doing this, and a lot of the tech, like the beam telepresence robot, projects your face onto a screen and lets you drive around. And there are hospitals that are using that. The unfortunate thing is that that specific company and several other telepresence companies have actually gone bankrupt in the past couple of years. And so a lot of that technology was not actually mainstream and readily available for hospitals just to deploy easily. So yeah, other questions?
Yeah, I have a question. Peter?
Yeah, go ahead, Gerald.
I'm in the medical device industry, and in about a year and a half, we'll be making very small parts that are implanted in the body and need to be combined with inserter and removal devices in a sterile kit. Are robots to the point where they can handle very small parts in a sterile environment?
Well, there are a lot of people who use robots in sterile environments for things like micropipetting and doing very fine motions. The thing about those robots is they tend to be big and they tend to be intimidating. So they're the kind of thing where we have the mechanical capability. We don't have the capability to take that mechanical capability and put it in a more human approachable, less scary package. So there, just to give an example, there's a root canal robot that's very good at doing root canals, but they have to cover the person's eyes with a blindfold when they do the root canal, because so far nobody has been able to not flinch when this giant robot is coming into their mouth with a drill. So I think the human factors aspect of this is very important, and we don't quite have that strength to weight ratio to make humanoid robots that are strong enough to be able to do a lot of these more complex tasks.
This would not be an environment with a patient. This would be manufacturing.
Oh, manufacturing, yeah.
Put them in a sterile container.
Yeah, picking parts and putting them in a sterile container, that's totally fine. There are plenty of robots, like Universal Robotics makes a bunch of arms that could probably meet your needs. And there are people, if you're doing this locally in Providence, there are a few people, if you email me, I can connect you with them, who work in the medical robotics field, who have experience with setting up those types of robots.
Thank you, Peter.
Yeah, no problem. Paul.
What do you hope happens to the 3 billion poor people, and how do we get there?
My hope is that automation and robotics permits the capability to manufacture services cheaper and cheaper, and that some of these economic inequalities get actually solved through mass production. And the other hope is that they get integrated into the world economy better, so that they actually have the purchasing power to be able to get out of poverty. I mean, I used to spend 10 years in international development prior to this, and my general assessment is that poverty is a failure of government more than a failure of the capabilities of the country. And I think if you can help people tap into economic opportunities outside of the economic opportunities within their country, they can thrive in the global economy and compete in the global economy. So I think that this technology, this avatar technology, will help people do that. Just like most telework technologies have helped people compete in the global economy.
I have a quick question about that. Kind of, as
Yeah.
you're building these robots, are you thinking about like the level of training that future users would need? I know you're still on the very much the, but like
Research
I was
side.
thinking maybe, you know, upskilling for manufacturing jobs is the next.
Yeah, so right now the interfaces are still being developed. It's still very much research. So I think that the training aspect is hard because you don't know exactly what interface you're going to be training on. But I think that there will be a need for training in this area in the future, and workforce development in this area. And honestly, I think that the companies that develop these interfaces, like, these are going to be unicorn companies. Like, they're going to create a lot of jobs. And the more people who are younger are working with these technologies and envisioning what those companies could be like, the more chance that they have to actually create those new companies and create the jobs that are going to be the future jobs that are going to replace the older jobs. But there is a huge problem with job displacement and retraining in the world right now, especially in the US. I mean, if you look at the federal job retraining programs and their success rates, it's really a painful situation. Not many of the people who get retrained in specific jobs end up finding work in those areas that they're retrained in. So yeah, we have to rethink retraining as well, as people are being displaced from jobs. Any other questions?
Peter, I do have a question for you.
Okay.
Great conversation thus far. Thank you so much. I'm very intrigued by that human factors element that you were talking about.
Yep.
I was watching some Boston Dynamics videos of their dog, you know, and as it was moving around, as it went to fall, I found like it triggered a human emotion in me, right? Which is I was so surprised. It's a mechanical thing that's falling, but yet I have this reaction. And so I'm kind of intrigued by how we're going to move into this world with robots and better maybe modulate our emotion, because it's a mechanical thing that we probably wouldn't have the same reaction should a real dog hurt itself, right? And you were talking about that root canal scenario, which is very real. So just how you led off the conversation today with the 1900s versus the 1913 car versus horse scenario. I wonder if there's any learnings from that, right? People knew how to react to horses at one point, but they probably didn't know necessarily what to expect from an automobile. Are there learnings from that we can kind of bring forward into this new land, or maybe somebody else is working in this space and has some great insights?
Yeah, I think there are learnings from the automobile. And there's some really interesting learnings from the automobile. Like the thing that has really amazed me about the spread of automobiles and that historical story is line painting and the formation of the rules of the road and the regulations by which people drive and actually are permitted to drive, because driving is not a right, it's something that you earn. And I think that if you look back at the history of line painting on roads was initially done by nonprofits. It wasn't a government function. And it was something that was trialed and experimented with before we actually settled on the lines that we have painted today. Like they're pretty standard country to country, depending upon where you are. So I think that sort of thing is going to happen with robots in the future as we start to see more of them. And we're starting to see more, like people are trying to do delivery robots on sidewalks. Like I think you're going to see a lot of standard setting around how robots interact with existing traffic patterns, with human pedestrians. Like there's a big concern with robots on sidewalks because like we've already seeded the streets to cars. Like before people would walk anywhere, and now like you have to worry about cars hitting you. And like people who are on sidewalks may have to in the future worry about robots being in the way. So yeah, I think there's a lot of discussions to be had around that, especially in terms of like accessibility, and diversity of experience. So yeah, and then to the general human factors question, like that human emotion to empathize for the robot is very real. People connect with robots that are made in a certain way. We actually created a database of robots called the ABOT database of different types of robots, and we found the more humanoid the robot, the more people will ascribe capability to it. And I was at the Economist World Gala a couple of years ago, and Sophia the robot was on the panel with me. And after that gala, the human panelists had maybe 4 or 5 people lined up to talk to us. There was a line almost 100 people deep to get selfies with Sophia the robot. So yeah, I think there's going to be something around the novelty. There's going to be something around uncanny valley. There's going to be something around human emotion. And then the final thing we have to worry about is actual robot abuse. I actually am very concerned about this because it desensitizes humans towards human abuse. So Pleo was a plush dinosaur robot that made a little sound if you hung it upside down. And that sound was a distress sound. And there were on YouTube for a period of time a series of videos that were essentially Pleo torture videos of people trying to make the robot make that distress sound and beating the robot up. And we have to be very careful when we're thinking about human factors and designing things on what kind of psychosocial behaviors we encourage to make sure that we aren't creating desensitization environments, because the risk of people becoming totally desensitized towards robots and that leading towards desensitization towards other humans is a very serious risk. So
if I could ask a question.
Yeah, sure.
From a regionalization perspective, are you collaborating collectively as a region to improve robotic quality as a collective region? And then Hyundai bought the lion's share of Boston Dynamics. So how will that impact that aspect of collaborative effort, the region, and being picked up by a offshore company?
Yep. So basically, the Boston metro area in particular is one of a few hubs in the US and in the world right now for robotics. So if you look at the hubs, you've got the Bay Area, you've got Pittsburgh, you've got Boston, you've got a lot of autonomous vehicle stuff out in Detroit. And this area, this region, I actually think is more of a diamond than a circle around Boston. It goes up to Manchester with DECA Robotic or DECA Research. It goes down to South Coast and Providence with like some underwater robotic stuff. But there's a growing talent pool in this region that is being fostered. And if you look at like accelerators like Mass Robotics, which is up in Boston, they're pushing through new companies. There are lots of new startups in the pipeline that are going to be employing this talent. And you're seeing people hop from company to company. So Amazon Robotics is based in both North Reading and Westboro. And like people are leaving Amazon after a few years and going to do startups. Just the same way they did with iRobot and Rethink Robotics. Now, to the international ownership question, that is a real issue. Like it's not just Boston Dynamics. Rethink Robotics got bought out by a German company when they went to Chapter 11. And this really stems from the fact that I think the robotics startup ecosystem is not focused enough. I mean, we're starting to see some focus in warehouse robotics like Locus Robotics and right hand robotics, but I think the startup ecosystem is not historically designing for a use case. They've been designing cool robots. They've been coming out of research labs, designing cool robots. And then the use case has been the afterthought. Like Rise, the climbing robot. They built the climbing robot first, and then they're trying to figure out the use case. I think what you're going to see is you're going to see more people moving towards finding the industrial application and building robotics specifically for that industrial application. So yeah, I hope that answered your question a little bit. Bob has his hand up, and then
and that's going to be the last question.
That'll be the last one. Okay.
Yeah.
Hey, thanks. Just fascinating talk. Thank you for doing this. I joined a little late, but I joined at the point where you were discussing communicating intent. And I thought that was really kind of an interesting thing to be grappling with, because I suspect that, you know, most of the people on this call couldn't tell you what they're going to do next, never mind like how the robot is telling you what you're going to do next. So I'm curious what that looks like from a planning perspective, and has that shed any insight on consciousness? Like, do you go back and work with people who are thinking about consciousness and what it means? Like, I'm going to get up and get a cup of coffee?
Yeah, so basically the hope of this intent communication is that it's not just robots. That's robots and AI frameworks being able to have shared mental models with humans. Okay, so just to give an example of some work that we've done with this, so we do a lot of work with partially observable Markov decision processes, which are basically a framework for making decisions. And the thing about POMDPs is POMDPs are, one, they're computationally expensive, and two, they sometimes get things wrong. So what we did is we create a system for the robot to share what it's thinking, share what its guess is of the object that we're referring to when we're pointing at an object in mixed reality by highlighting that object with a sphere. Okay, so it could create a sphere around the object, and then that object would be identified both to the human and to the robot, and we could say, yes, this is the same object, we agree on this. But then we realized that this technology could go further and could be used by humans to teach the robots about objects. So we played around with a little database system where we would teach a robot how to flip a light switch or open a cabinet, okay? And we would create a symbolic grounding linguistically of like, this is what it is to open a cabinet, this is what it is to flip a light switch. And then you could give, and then we'd map out in the space using mixed reality by highlighting objects what the different symbolic breakdown of the space was. And then you could just give verbal commands to the robot, like go to the microwave and open it up. And the robot would understand where the microwave is and how to open it. And the great thing about this system is, instead of like hard coding that, you can go into a new space with the mixed reality headset and be able to say, okay, in this space, that's the TV, that's the microwave, do the labeling very easily and intuitively for the human. So yeah, I think this is going to get to like those tougher AI questions. And ultimately, I mean, I think that like the consciousness question's going to be a really hard question. We're very far from that in AI right now, but I think that this is going to be one of those paths towards sharing information between humans and robots that permits us to create conscious robots that actually are understandable to people, and helps with explainable AI and all of those problems that we're facing with artificial intelligence right now.
I think what I'd really like is the glasses that two people can wear, so that we're sure they're talking about the same thing. Never mind.
That'd be great.
So, thanks.
Excellent.
Well, thank you all, and thank you, Amy.
Thank you, Peter. That was fascinating. I wish we had like another hour for the Q&A part, but we will do this again with Peter Haas very soon. We'll bring him back for something else. Hopefully, I'll connect with him afterward.